stronger than steel, lighter than aluminium, and woven like fabric. Carbon fiber is one of the most extraordinary materials ever created by human ingenuity. The story begins in 1879, when Thomas Edison baked bamboo and cotton threads at extreme temperatures to make filaments for his incandescent light bulb. Edison had unknowingly created the first commercial carbon fiber. Those carbonized strands were pure carbon copies of the original material, glowing bright inside glass bulbs. For decades, carbon fibers stayed in the shadows. Then, in 1958, physicist Roger Bacon discovered graphite whiskers at Union Carbide's Palmer Laboratory in Ohio. Bacon's whiskers were astonishing, a tenth the diameter of a human hair. They could bend without breaking and had strength far beyond anything steel could offer. By 1964, scientists in Japan and England found the key precursor, polyacropan. Over 90% of carbon fiber is still made from it today. So how is carbon fiber actually made? It starts with spinning pan polymer into long, thin precessor fibers, like pulling taffy into delicate white thread. Those fibers enter an oxidation oven heated to around 300 degrees Celsius in open air. The molecular structure transforms, turning the fibers black. Next comes carbonization. The stabilized fibers pass through furnaces reaching up to 1800 degrees under pure nitrogen, burning away everything except carbon. What remains is a fiber that is over 95% pure carbon, just 5 to 10 micrometers thick, lighter than a feather but with the tensile strength of a superhero. These microscopic strands are then bundled into tows, thousands of filaments twisted together like rope. From there, they can be woven into sheets, braided, or molded into any shape. The magic happens when carbon fiber meets resin. Combined into a composite, the material becomes incredibly rigid and strong, a partnership greater than its part. Weave pattern matters too. A plain weave creates a tight checkerboard. A twill weave makes a diagonal pattern. And unidirectional layups channel all the strength in one direction. Different weaves serve different purposes. Racing car body panels use twill for flexibility, while aircraft wings use unidirectional layups where maximum stiffness is everything. Now let's talk about cars. The McLaren F1 in 1992 was the first road car with a full carbon fiber monocoque, a single shell protecting the driver like an eggshell. Today, supercars like the Lamborghini Aventador and McLaren 720S use more than 50% carbon fiber by weight. It cuts body mass in half compared to steel. BMW's i3 pioneered mass-produced carbon bodies in 2013, and every kilogram saved extends battery range by roughly 8 to 10%. Motorcycles benefit just as much. Carbon fiber frames, swing arms, and fairings shed weight where it matters most, sharpening acceleration and cornering at the same time. And then there are helmets. A carbon fiber shell absorbs impact energy while staying feather-light, protecting riders without adding fatigue on a long ride. Beyond vehicles, carbon fiber shapes the world of sport. Tennis rackets, golf clubs, bicycle frames, and even prosthetic running blades are built from this remarkable material. More than half the airframe of a Boeing 787 Dreamliner is composite, saving fuel on every single flight. Architecture and construction use it too. Bridges are reinforced with carbon fiber wraps, and earthquake-prone buildings are strengthened without adding heavy steel bracing. The challenge ahead is cost. Raw carbon fiber still runs around $15 per kilogram, 10 times the price of steel. Bringing that down would change everything. From Edison's glowing filament to hypercars and spacecraft, carbon fiber has quietly become the backbone of modern engineering. And its best chapters are still being written.